NASA and International Astronomical Union just released new data on Atlas, and what scientists feared is now confirmed. The preliminary post-perihelion images show no evidence of the massive gas cloud that should be there if this is a natural comet. Let me say that again. The cloud that physics demands must exist isn't showing up in the data. This changes everything. The Minor Planet Center and NASA's Jet Propulsion Laboratory just published their analysis, covering October 31st through November 4th, the critical period right after Atlas emerged from behind the Sun. And the numbers tell a story that's becoming impossible to explain with conventional comet physics. Let me walk you through what just happened, and why the natural explanation is now in serious trouble. First, the non-gravitational acceleration has been confirmed. It's now measured at 3.7 sigma, which in science terms means it's statistically robust. This isn't noise in the data. This isn't measurement error. Something is genuinely pushing Atlas off its gravitational trajectory. The acceleration has two components, both in Atlas's orbital plane. A radial push away from the Sun at about 94 kilometers per day squared at perihelion, and a transverse push sideways at about 31 kilometers per day squared. Think of it like this. Imagine you're driving a car, and suddenly the car accelerates forward and swerves to the side, without you touching the pedals or the steering wheel. That's what's happening to a 5-kilometer object in space. Now here's where the physics gets really interesting and really problematic for the natural explanation. When something accelerates in space without an external force, it must be ejecting mass. Newton's third law, action and reaction. If Atlas is speeding up in one direction, something must be flying off in the opposite direction. It's the rocket effect. Avi Loeb did the calculation using basic momentum conservation. If this acceleration comes from natural outgassing, from ice sublimating into gas and pushing the object, Atlas must have lost at least 13% of its total mass during the 1-month perihelion passage. 13%. Of a 33 billion ton object. That's over 4 billion tons of material ejected into space in about 30 days. For comparison, that's like if Mount Everest suddenly evaporated and turned into a cloud of gas. That's the scale we're talking about. And here's the critical point. You can't hide 4 billion tons of gas and dust. If that much material was ejected, it would create an absolutely massive, brilliant, unmistakable coma surrounding the nucleus. You would see it in every observation. It would be the dominant feature. But the preliminary post-perihelion images, the ones just released, show no evidence for it. No massive cloud, no dramatic expansion of the coma, no enormous debris field that would indicate 13% mass loss. This is the test we've been waiting for, and the natural explanation is failing it. Now, to be fair, let me explain both scenarios because this is where it gets fascinating. Scenario 1, natural comet. If Atlas is a natural comet experiencing extreme heating at perihelion, it should be outgassing violently. The thermal speed of gas molecules at Atlas's surface temperature would be around 300 meters per second. At that ejection velocity, you need to lose 13% of your mass to produce the observed acceleration. And that 13% figure assumes the maximum possible thermal velocity for a natural comet. If the gas is moving slower, you need to lose even more mass. But here's what we're actually seeing. Atlas brightened by a factor of 5 in green band observations between October 5th and November 4th. 5 times brighter. That sounds like massive activity. Like exactly what you'd expect from extreme outgassing. Except, there's a problem. The brightness increased, but the massive coma isn't showing up in the images. Now, some scientists argue this could be ionized carbon monoxide, CO+, which can produce blue light and unusual brightness without requiring as much mass loss. That's a possibility. CO plus emission could explain the blue color and some of the brightening, but CO plus doesn't explain the acceleration. You still need to eject mass to produce thrust, and preliminary images aren't showing the massive debris field that should exist. Scenario 2. Technological propulsion. If Atlas has an engine, if there's an artificial propulsion system, everything suddenly makes sense. An engine can expel exhaust at much higher velocities than thermal sublimation. Chemical rockets expel gas at 3,000 to 4,000 meters per second. Ion drives can reach 30,000 to 50,000 meters per second. Nuclear propulsion, even faster. At those velocities, you don't need to lose 13% of your mass. You might only need to lose 1% or less, maybe even a fraction of a percent. A hot engine would explain the blue color. High-temperature combustion, or plasma, produces blue light. The sun is yellow-white. Something hotter than the sun would be blue. The 5 times brightness increase, engine ignition, thrust application, a propulsion burn. The directional acceleration with radial and transverse components, precisely what you'd expect from a guidance system making course corrections. And critically, with an engine, you wouldn't see a massive debris cloud. You'd see exhaust, controlled thrust, not chaotic sublimation of billions of tons of ice. So here's where we are. We have an object that accumulated 10 statistical anomalies with combined odds of 1 in 10 quadrillion is exhibiting confirmed non-gravitational acceleration. Got 5 times brighter at perihelion, turned blue when it should be red, and preliminary images show no evidence of the massive gas cloud that natural physics demands. The data from NASA and JPL is official. The acceleration is confirmed at 3.7 sigma. The brightness increase is documented. And the absence of the massive coma is preliminary but increasingly clear. This is the clean test Loeb has been talking about. If massive outgassing created the acceleration, there must be a massive cloud. If there's no massive cloud, something else is creating the thrust. And right now, preliminary post-perihelion observations aren't showing that cloud. Now, let me be crystal clear about what we're saying and what we're not saying. We're not claiming definitive proof of artificial origin. Science doesn't work that way. We're presenting the data, the measurements, the observations, and the 2 competing explanations. What we are saying is that the natural explanation requires specific observable consequences. And those consequences aren't appearing in the preliminary data. That's significant. That's worth paying attention to. The coming weeks will be critical. More observations are being collected. More telescopes are turning toward Atlas. More data is flowing in. If the massive coma appears in higher resolution observations, if we detect the billions of tons of ejected material, then the natural explanation survives. Atlas is an exotic but ultimately natural comet with unprecedented properties. But if observation after observation continues to show no massive debris cloud, if the coma remains modest despite confirmed acceleration, then we have to seriously consider that we're looking at something that doesn't fit the natural category. Not because we want it to be artificial, not because it would be exciting or dramatic, but because that's what the data is telling us. Remember the 10 anomalies. 1. Trajectory aligned with planetary disk, 0.2% probability. 2. Sunward jet-defying physics. 3. Million times more massive than Oumuamua while moving faster. 4. Perfect timing for planetary approaches while hidden from Earth. 5. Industrial alloy metal ratios. 6. Only 4% water when comets are 80–90% water. 7. Unprecedented negative polarization. 8. Arrived from WOW signal direction. 9. Brightened faster and bluer than any known comet. 10. Non-gravitational acceleration requiring massive mass loss that preliminary images don't show. Each anomaly individually might have a natural explanation, but all 10 together in one object With the critical test now showing the expected massive coma isn't appearing, the probabilities compound, the coincidences multiply, and the natural explanation struggles to accommodate the full picture. This is investigative science at its most exciting. We have an object that defies easy categorization. We have data that challenges assumptions. We have observations that demand explanation. And we have a test, a clear, definitive test. Show us the massive gas cloud or admit that something else is creating the acceleration. Preliminary results say the cloud isn't there. Final confirmation requires more observations, more data, more analysis. But the direction is becoming clear. Either we're witnessing the most anomalous natural comet in history, with properties so extreme they break every pattern we've ever observed, or we're looking at something that falls outside the natural category entirely. The data will decide. The observations will provide the answer, and we're watching it unfold in real time. This is why Atlas matters. This is why every new data release is critical. This is why scientists around the world are watching with intense focus. We're not just observing an unusual space rock. We're conducting a test that could answer one of humanity's most profound questions. And right now, as of November 4th, with official data from NASA and JPL, the preliminary answer is deeply intriguing. The massive cloud that should be there isn't showing up. The natural explanation is struggling, and the alternative, the one that seemed too extraordinary to take seriously just months ago, is looking increasingly difficult to dismiss. Stay tuned, because more data is coming. More observations are being analyzed, and what we learn in the coming weeks could rewrite our understanding of what visits our solar system. Follow for updates, because this story is far from over. The test results are in, and they're not what the textbooks predicted. Something extraordinary is happening, and we're watching it together.